So in this problem, we're going to find the case smallest element in a sorted matrix. So we're given a int matrix which is sorted, and we're going to output a int as the case smallest inside the matrix. We take this matrix as an example, and we're going to solve this problem by using Dijkstra's algorithm. So the way we do that is we maintain a priority queue and we make it as a min heap, and it has a size k, and we will it will help us to find the k smallest element. So suppose we have a starting point at 0, 0, which is this point, and we will offer this point to the priority queue, and then we generate this point. We pull it out from the PQ, and we expand this point. We pull it out from the PQ, and we generate its neighbors. So in here we define neighbors as the point we define the neighbor as the point below it and the point on its right. So we will put these two neighbors inside the PQ also. And for next step, we will expand another point from the PQ. Since these two elements inside PQ has the same value, we will expand any of it. It's the same. So suppose we are going to expand the 0, 1 point, which is this one, and as we did before, we will generate the neighbors, which is 1, 1 and 0, 2. And if we keep expanding point, we will expand this point with the value of 2, which is 1, 0, and we generate 0, 2 and 1, 1. So now we have a problem because we know we already have 1, 1 inside the PQ, and we couldn't have two 1, 1s inside the PQ because we need to find the k smallest. So the duplication should be checked. So we're going to use a Boolean matrix with the same size of the input matrix. And after we generate 1 point inside the PQ, we're going to turn that point to true to show that this point is generated. So next time, if other points wants to generate the same point, they will know it's generated, and it will not be put inside the PQ again. So now we can start coding. We need to build a class of point, and the field it should has int x and int y as the coordinates, and it also has a int key, which is a value. And now we build the constructor. So point okay. So now we have our class solution. Let's build our function signature. So public int cake small. So first we do sanity check. If matrix is empty or matrix has a length of 0, or matrix has a height of 0. We return the maximum value of integer. Okay, so now we need to build the priority. Oh, sorry. We want to build the Boolean matrix first. So we call it visited. So the size should be same as the matrix. So sorry. And we need to build the priority queue. And we're going to put point inside. It will have a size of k, and we need to write a new comparator for it. So to compare 2 points, we'll use this compare function. So we'll compare P1 and P2. So we want to return a 0 if P1 has the same value as P2. To show they have the same priority. Otherwise, if P1 has a smaller value, it will have a higher priority. Okay. Okay, now let's new a point as a start point. So so the matrix should be 0, 0, and the value of 0, 0 point. We will put the start inside the minimum heap. So and don't forget to turn the Boolean to true. so visited. So now we will have a for loop and let it loop n minus 1 times. So we have this current point pull out from the min heap. So we're going to check its neighbor. So check its right neighbor. If its right neighbor isn't visited, we will offer its right neighbor to the PQ. Also, we check its right neighbor. It's below the neighbor below it. So okay. So after we repeat n minus 1 times, we should have now the minimum heap with the top. We will have this minimum heap, and its top should be the case smallest value. So we need to return. Okay, and for time complexity. So for time complexity, so we build a PQ. The time should be O K. Well, well, if we heapify the PQ, we will have a OK time, and we're going to check the first K element. So we will have this OK for loop. So the time complexity should be OK plus OK, and it's still OK. And the space complexity where we build a visited in here, which is n squared. Well, if there are n points, so we build a visited in here, so the time. Well, not really. Sorry. So the space complex. Oh well, yeah. So we built a visited matrix here. Suppose we have n points in total. The space occupied in here should be O n. And we also build a heapy file. We also use a min heap which takes OK space. So the summation should also be O n. So we know n is definitely larger than k.